it!
The purpose of this lab is to find the unknown concentration, pH, and pOH of 3 acids using the titration technique. Titration is a controlled addition and measurement of the amount of solution of unknown concentration required to react completely with the measured amount of solution of unknown concentration. The endpoint is the point in titration at which an indicator changes color. Indicators are a sort of pH meter. The equivalence point is the point at which the two solutions used in a titration are present in chemically equivalent amount. These are the neutralization's balanced equations. The neutralization equation will result in a water and a salt.
Okay, so the safety procedures in this lab are to always have your hair pulled up, especially if you're a girl, so that none of your hair gets into the chemicals. To always be wearing your apron so no chemicals or anything gets onto your clothes or skin. Wearing gloves to also protect your skin from the chemicals at all times. Wearing goggles to protect your eyes from the chemicals. And if chemicals do get into your eyes or on your skin, you would use the sink, the shower, or the eye wash right away and alert your teacher. And lastly, make sure that all flasks and beakers and just objects like these are away from the edge so you never end up pushing them off. The first procedure in the lab was to pick 2 burettes, one used for acid, one used for base. The one that was used for acid was rinsed out 3 times with the acid used, and the one used for base was rinsed out 3 times with the base used.
Acid was added to the burette above the 0 milliliter mark and then calibrated to the 0 millimeter mark to release air bubbles from the tip.
The initial volume in trial 1 was recorded at 0.00 milliliters, and then 8.00 milliliters was released into the flask to make the final volume for trial 1.
So we're releasing the acid 8 millimeters down, so we're going to be going from 8 to 16, and that's going to be the acid we're going to use.
The initial volume was subtracted from the final volume to find the exact volume to the nearest 0.01. Then 3 drops of phenolphthalein indicator were added to the flask.
Adding the phenolphthalein for the 3rd trial. The other burette was filled with the standard base solution of sodium hydroxide above the 0.0 milliliter mark. Then some of the base was released to the 0.0 milliliter mark to release air bubbles from the tip.
In the flask, the acid in the indicator was then placed under the base burette. The base was slowly released into the flask, and the flask was continuously swirled.
Right? Yeah. Now we are adding the base to the acid until it reaches its endpoint.
We're swirling it so that the acid mixes in.
Once the solution reached a faded pink color, after being swirled continuously for 15 seconds, the solution had reached its equivalence point and no more base was added.
That's 9.9.
That's perfect.
That's good. The initial reading was subtracted by the final reading to get the exact reading of the base.
To find the pH of acid A, we need to start with the base. We know that the base average molarity is 0.0195. So that is our molarity that we're going to use to find the average moles used. Our average volume used was 24.90 milliliters. But in order to find the moles used, we have to plug it into liters. So we're going to divide that by 1,000 to get 0.0249 liters. We're going to multiply that by the molarity to get 0.000490 moles. That is the amount of moles used for NaOH. We're going to plug that back in and use the balanced equation to find the average moles used of the acid. Since it is a 1-to-1 ratio, it's going to be the same. Now we're going to plug that in to find the average molarity. Our average volume used was 8 milliliters, so we're going to turn that into liters as well. And then we're going to plug in the moles of it. And there we will get so that is our average molarity. Now, since hydrochloric acid produces 1 hydronium ion per each mole, we're going to plug that into our hydronium concentration. Then we're going to use anti-log to find the pH, which is 1.17. We're going to subtract 14 from that to get our average pOH, which is 12.83. We're then going to use the equation which we're going to raise 10 to the negative POH, and that's going to be 1.47 times 10 to the negative 13. We're going to do the same equations on this side. This is going to transfer into our OH concentration, which we're going to use to find our POH using the anti-log. This is 1.71. We're going to subtract 14 from we're going to subtract 1.71 from 14 to get 12.29. And then we're going to raise 10 to the negative pH to get This is our own data and 4 other groups, and we have the averages on the bottom. To take the averages, we added our own and 4 others and then divided by 5. Our averages for A was 1.20 pH and 0.0624 molarity. Our average for B is 1.54 pH, 0.0287 molarity, and our average for C is 1.67 pH and 0.0129 molarity.
One of the possible errors in this lab could have been not swirling for 15 seconds after the base was added.
Another error could have been adding an extra drop of base into the solution, affecting the results. This is the perfect amount of base that could be added to the acid to neutralize this leak. Yes, it's neutralized. Thanks for coming along to our experiment.
The pond is saved!